I have the good fortune of introducing probably the person who's had the largest impact on the technology community in Pittsburgh over the last 20 years, or however long, Andrew, you've now been in Pittsburgh, 25 years, I guess. Our keynote speaker today is Andrew Moore, who is the CEO of Lovelace AI. And for you of you who are computer science nerds, you'll understand the name very well. Andrew's background is he was a professor here at Carnegie Mellon. Andrew, when did you come to Carnegie Mellon? What year? First time. 95. So he came in 95 in the computer science department. Was then Google very unsuccessfully tried to recruit him to join Google. And they kept asking him, why won't you join? Why won't you join? And he said, because I love Pittsburgh and I want to stay in Pittsburgh. And that was the genesis of the Pittsburgh office. So instead of Andrew having to go to Google, Google came to Andrew. And, you know, that was obviously a very, very important event in Pittsburgh's technology lineage. He stayed at, and he can give you more details, but he stayed at Google for a period of time, was recruited back to Carnegie Mellon to be the Dean of Computer Science. And that's probably the second most important thing that happened in Pittsburgh technology, because if you look at the rankings of where they were ranked when Andrew took over to where they are ranked today, U.S. News and World just came out with their newest reports, number one in computer science, number one in information systems. Every discipline, sub-discipline under computer science, Carnegie Mellon is ranked either first or tied for first. And a lot of that is because of the professors that Andrew was recruited to the area. So Andrew, thank you for that very much. After serving as dean for a period of time, he was recruited back to Google to run AI and cloud for Google, again here in Pittsburgh, increased the employment at the Google office to over 800 people, and then recently decided to go out and really change the world through a new startup called Lovelace AI, which we were fortunate enough to be one of the early investors in, and strictly because we believe in Andrew so much. And so, Andrew, I'll let you take it away, but Andrew, thanks for everything, and I really cherish the fact that I consider you a friend.
Thank you. Thank you very much, Jay. Who are you again? Thanks, everyone. I'm very glad to be here today. I've been popping in and out and really enjoyed everything that I've seen, and I love the quality and interest in the questions around all of this. I wanted to take an opportunity to go into somewhat more of a technical area around artificial intelligence, something has been keeping me awake at night for a while, and was part of my reason for I really wanted a chance to gather a group of folks together here in Pittsburgh to address this really important question. And it comes down to, what do we do when we need to put artificial intelligence-based automation in very difficult areas of business, commerce, civic life, and national security? What do we do with serious artificial intelligence? And how is it different from what we're doing with all these really exciting and important areas of artificial intelligence where you can perhaps get away with fielding a system which will not cause immense damage if it ever makes mistakes? That's why we created Lovelace. And today I'm going to talk about some of our experiences here in Lovelace in situations where we are pulled by many different stakeholders and factions in large organizations we work with, some of whom want us to say the new generation of generative AI is the full solution to everything, and some who frankly want us to pretend that it's 2020 and that we're living back in those worlds. And unfortunately, I vehemently disagree with both sides. I'm going to explain to you the reasons why I think you have to have a bit of both. And someone who says it's all done, just a couple more bits of work from Anthropic and OpenAI and we'll have finished with AI, that's absolutely false, and I will fight that tooth and nail. And then the people who say, oh, this stuff is flaky and unreliable, we shouldn't introduce it, there are still antibodies like that in every big organization, every government department, every bank, and you have to politely fight them as well. So I'm going to illustrate with Tom Cruise as my graphic as to what's going on in the world of enterprise AI. By enterprise AI, I mean those situations where frequently the CEO has bought into the fact, and I know that you guys at Deloitte are very familiar with this, bought into the fact that they live or die depending on whether they become AI first. This has bubbled down to the rest of the organization, and someone has often been put in charge of literally reducing headcount by 70% over the next 3 years in order to bring in automation. And there are so many parties and the dramas that you see with people who are living in this world, I'm going to encapsulate now with the help of my good friend Tom. So, first kind of happy people are the sellers and the big seven, as were mentioned. There is extraordinary investments in the marketing departments of those folks, trying to make us believe that we are a year or two out from the whole game being over, and they, the AI providers, will have solved all the needs for automation for almost any job that doesn't require physical movement of objects. That's false, but folks are giving that impression. Then you get contempt. This is the sad Tom Cruise. And there are two kinds of contempt. There are, and I have sympathy with both of them. There's someone who owns a department which has got maybe 25,000 analysts or contact center workers or knowledge workers who wants to still run a department and have a huge number of people reporting to them. And those folks, I don't particularly sympathize with the idea that they're going to try to make their whole organization less productive just so that they can continue to have a powerful role. There is another kind of contempt, which are the people who've been burnt. And I will say, and again, I'd be very interested, many of you in this audience have experience either being part of large enterprise organizations or consulting for them or providing guidance for them. I cannot think of one where the top level leader, be that a general or a CEO, hasn't come to me and said, Andrew, we've tried 5 things with AI and none of them have actually worked. And so even now, you might think that it's crazy to talk like this. There is a danger of an AI winter where people start to give up on certain aspects of large-scale enterprise AI deployment because over and over again, they've been shown something very shiny and people have forgotten to actually implement it. Scientists and engineers are a little confused right now about all of these things. I do see among great engineers and researchers, a few people feeling insecure that they won't be needed soon. I don't think that's true, and part of what I'm going to show you explains why I don't think that's true. I also do think it's incredibly important for Carnegie Mellon in particular to produce thousands of people every year who are going to lead in this new world, and I don't want those people starting to think that they should instead sign up to be an onion farmer in Nebraska because there's not going to be any work for them. That would be untrue. And then, as I mentioned, senior leadership are all over the map. Sometimes they will tell some groups of folks, I don't care what happens. If you don't do anything, I will fire 3/4 of your staff in 3 months and you will be left holding the bag to automate quickly. Next hour, they're shouting at Sam Altman or Thomas Kurian or someone, why the heck have we spent so much money with you guys and all I'm getting is people having a slightly less time wasted scheduling their calendars. So this is the playground that I live in right now, and this is my personal sense of what we do about that playground. One big misconception I'm seeing is folks imagining that intelligent behavior of humans, the behavior you see in software engineers, the behavior you see in a call center operator, the behavior you see in a marketing analyst, that these all correspond to the same kinds of thinking. The first three on my list there, for those of you who are back, the first three are puzzle solving, summarization, and chat. It's amazing what technology can do. I would not have bet 5 years ago that we would see the level of performance that we see now from our tools. The one at the bottom is another type of cognition called investigation. Now, an investigation is something where you are asking someone intelligent or something intelligent to put together many clues. And these days, often it's thousands, sometimes millions of small pieces of information joining together to form a decision. These are the kind of things which 5 years ago, folks were building big data warehouses or what they would call lake houses or other things like that, just to get their data in good shape so that they could ask these kinds of questions. Those questions involve really sophisticated aggregation and search and modeling of huge amounts of data. When we send an unarmed agent or large language model or MCP server out to do one of those bits of work, it's not well suited to it, and it will get stuck with relatively weak answers. And so myself and a bunch of colleagues in the industry, many folks in research organizations, have been desperately searching for what else needs to be there in order to help these folks do their investigation. So let me give 3 examples in national security. These are all folks who, as you can imagine, there has been much discussion of what you can do to use artificial intelligence to automate them. None of those projects have been successful so far. Probably rightly so, like it would have been terrible to have actually tried to deploy these. An analyst whose job is to synthesize lots of data. When an LLM is doing reasoning in its embedding space, and you ask it a general thing about perhaps hundreds of thousands of moving objects on a giant screen, it can only focus on a few of those while it's thinking in embedding space, or it can call some pre-existing tools to do its work for it, but it can't give the same kind of answer that those analysts are giving. Similarly, for watch officers, for a watch officer, they are often having to just do a very simple job, like of all the ships about to go through the Panama Canal, I'm going to stop and search 3 of them every day for weapons smuggling. Which ones do I have to choose? And that does involve complicated detective work, not something that a Claude-like software engineering intelligence, nor a conversational or summarization intelligence is able to do. And then a commander themselves. Commanders have always been asking for things to help them make better decisions. And no commander, by the way, I've ever met has asked for something to make lethal decisions for them. But again, there has not been the success you might believe there has been in applying the current suite of generative AIs to those problems. And so what I'm often faced with is asked to help out with genuine need to do automation here. There is a need in the world of national security. Whether we do it or not, China is going to be doing this. It is going to be bringing in automation. But the first 2 or 3 solutions that people try are the ones that they might believe they should try, having read a few Economist articles or seeing YouTube videos of a LLM celebrity talking. They might believe it's going to be relatively easy, and it's not. So my answer to them is, if they do want to try to put all generative AI in, that's a bad idea. And I don't have to fight that battle anymore, because any serious bank or military organization or military intelligence organization has already tried this and it's failed. So at that point, you do see the stalwarts of the old days remembering how simple their life was before they woke up every day wondering if their job is going to be there in a month. Those folks are fighting back, saying something like generative AI is dangerous or impossible or hallucinates too much, we shouldn't do it. Both of those are terrible answers. What I'm going to do now is give you my strongest reasons, if you find yourself fighting someone from either of those camps, how to fight them. I'm then going to, if we get time, just because I bet there are some computer scientists in the audience, I'm going to show you something algorithmically interesting. I hope we get to do that. And then I'm going to take questions. So let's talk about these kinds of things. I've already given you a hint of some of these investigation type things where you try to bring in a generative AI. Imagine for a moment that your job is to figure out what's going on in an environment where your opposition really wants to hide what's going on from you. And perhaps you point your artificial intelligence at lots of telemetry about the movements of vehicles, perhaps ships, perhaps trucks, perhaps aircraft going into or near a specific port somewhere. And you say, try to find me signs of something illicit happening. The answers you will get are from, you can do that right now with Claude or Gemini Deep Research. You can point it at a huge repository of information with a RAG model or something, ask it to find something. And depending on exactly how the prompt works, you will get 10,000 answers which scare the pants off you to do with apparently strange things and a very, very strong descriptions by the LLM as to why this is something you should freak out about right now. Or if you've got some sort of token budget and you ask for a quick summary answer, you will get a shallow answer which might mention a few of the concepts involved and give you a generic answer like, yeah, I believe you should be watching out for ships that are coming in at a strange time of day and have this flag and this problem with their manifest. You get a generic answer which your humans already knew. Now, the real kind of investigation in this particular case that was needed was something which required a huge amount of spatial statistics of the kind that humans know how to do. Those spatial statistics by themselves were not finding much, but when they were combined with an LLM, they immediately figured out something, a huge tell that this adversary was using one trick to conceal information. And when you looked at enough sources at once, you realized that that trick could be detected. So that was, for me, an example where I would not have been able to do this 5 years ago because the generative AI would not have used the right tools, and but they would also not have been able to bring, in this case, there was at least 25,000 pieces of information to solve a kind of game of Sudoku in order to diagnose what was really going on. Another example of someone who tried to avoid generative AI was a big anti-money laundering instantiation. As many of you know, anti-money laundering is a very important thing for most banks. It's been done, even up until recently, mostly by old-fashioned rule-based systems. And with some controversy, a few folks have started to bring in machine learning-based systems, which usually do a pretty good job. But when, in a major deployment that my team was involved in, we used just standard artificial intelligence using the standard fraud signals. It did a really good job, but it was only when we connected it to something doing, I will say, Claude-style, higher-level analysis of what was happening that the system spotted new classes of anti-money laundering fraud which it hadn't been trained on. And that, to me, was actually my first huge wake-up moment that we cannot dismiss generative AI for these investigative things. It is much more powerful to use these two things together. This one, I hope that our generous sponsors from Deloitte will back me up on. But the thing which, it's such a simple comment, but this one I don't have any answers for. There is no such thing as self-deploying AI, so that even if Dario or or one of the other celebrities stands up on stage and explains how there is this piece of technology which can automate this thing, I'm pointing at you, we know that you're still talking to a CEO, probably 20, maybe 30 or 40 different business managers, or the equivalents in the military world, just to start thinking about how you would put an automated service around this in place. And then you are doing lots of human ingenuity work to figure out which of the regulations which are getting in your way are real and have to be respected, which of them are a sign of a piece of overregulation. And by the time you've started to do that work, you've done probably half the technological job that you would have done 5 years ago when we were deploying AIs without any generative AI in them at all. That piece of automation has not gone away. Basically, I'm sure you've talked about this earlier today, the change management involved in bringing in something like a anti-money laundering system or a counter child sex abuse materials system into a blockchain, anything like that, you're doing massive amounts of organizational work, which extend beyond the organization, just to deploy this. And any notion that somehow, because it's generative AI, someone's going to vibe code a solution is really irresponsible, and I go nuts when I see an AI person claim it. I don't think I'm going to spend all the time here because I want to take some questions and so forth. So I'll just mention a few other things. It can be incredibly slow and expensive to avoid using generative AI in projects. And in particular, I will give you a good example here of at Google, and this is not a trade secret or anything, one of the things that Google Pittsburgh team did very successfully was build up all the technology behind Google Shopping and its knowledge graph, understanding of all the products in the world, what their features were and all of that. When it was doing that, it at times had thousands and sometimes getting into the tens of thousands of human raters doing human connections, making sure that two different projects weren't decided to be the same, or one product wasn't described as being multiple things, all of those kinds of things. Vast discussions, for instance, as to whether edible underwear goes in the food department or the soft goods department. So humans involved with that made any project like that really expensive. And in the case of Google Shopping, which was bringing in billions of extra dollars of revenue, it was well worth it. Now, we don't need to do that. We can use generative methods to replace all of those humans, and I can now courageously build equivalent systems in a week, which were previously 2 or 3 years of setting up the organization, setting up all the operations for it. Primarily generative AI is also incredibly expensive, and we do have customers who need us to do the equivalent of 100 Google Deep researches, which would cost $100+ each every minute over a period of months to be understanding and diagnosing certain kinds of dangerous activity. That would result in budgets and power station uses which are astronomical. I personally am really fighting against that. As you instead tame your generative AIs to use efficient algorithms where they can, you get huge payback from that. So again, I have no time for someone who wants to stay on both sides of these divides. Other things, I want to tell you about this, but I'm not going to. Let me just give you one quick example of this, which needs to encapsulate this problem. When you ask an AI a question, there's one way of categorizing them, which I'm going to take a phrase from physics, where you do things called 1-point test, 2-point test, 3-point test, 4-point tests. Loosely speaking, a famous 9-point test in physics is if you're looking for near-Earth objects orbiting which might hit the world, you are having to search over all 9 tuples of observations of little dots out there in the solar system, for each of them to fit them as to whether or not they might all come from the same object and figure out if they've got a trajectory coming to Earth. So the algorithm looks like you're saying, those of you who do computer science, 9 nested for loops over all your things you've ever detected, and then run a test on them. And of course, that's monumentally expensive. And you can't do that. A good computer scientist, or physicist for that matter, from graduating from Carnegie Mellon, will work with Claude and come up with something which avoids the expense of doing that and makes it something that can work in real time. If, on the other hand, I was to run my company by just asking the AI or expecting a customer to figure out how to do that, all that will happen, and I see this happening all the time, is the customer complains, your AI is really expensive, it's very valuable, but I'm going to have to build another power station to do all of this, and things go that way. So in this particular example, one version of the 1.2.3 point function is, as you can imagine, in intelligence analysis, or actually for that matter in financial fraud, you found one bad person, you want to find out who they're collaborating with. Another version of that is in a whole network where you think, for example, there might be pairs of ships which are illegally doing ship-to-ship transfers. You want to look over all pairs. Sometimes, if you're looking for the signs of, God forbid there's another 9/11 type situation, you might be looking for groups of 4, 5, 6 people who individually or in pairs or in triples look like they are randomly wandering around, but who there's actually statistical evidence they're working together, and when you put together their expertise level, they're a threat. So all of those things are things where you need really clever computer scientists in the room, empowered by really powerful coding agents to solve the problems. This happens all over the place. And this is an example, this is just the South China Sea, an example of tracks from just, I think it's 2 hours of data, where it's very common that you have to have systems alerting for any pair of ships which are doing something which indicates they're working together, that they're trying to conceal. And when you look at this problem, it looks like you're saying, for all pairs of ships over all time, do this test. Now, the computer scientists in the room will know that you can be faster than that using this trick. If you ask anything about all pairs of ships in this area, you break it down into 3 questions. You ask for, well, do a computation of all pairs of ships in this box, do another computation of all pairs of ships in this box, and do a third computation about ships which are sort of transitioning between these 2 things. Now, you've decomposed your problem there. If you keep decomposing it like this, your computer suddenly starts to realize that, wait, you're asking me for all ships that have been in this box or close to ships in this box. It can't have happened because no ship goes more than 30 miles an hour. And you start to see a trick there. So here is a little tally of Claude and one of my CMU graduates, computer scientists, working together, where it was an operational problem that it was 30 minutes to run the analysis for someone. A version 1, I think this was done using the agent, so the odd ones are the agents and the even ones are the human beating up the agent, got it down to 120 seconds. That's still not enough if you're actually looking at more than this, and you're looking at more modes of transportation, and you're taking into account trucks and aircrafts and other signals. So it had to go down. Each of these steps, with each of these things, if I had just a human or just an agent, it would have ended up somewhere up here. As it is, we got this computation down to 91 microseconds. That means that there's massive scale monitoring now for something very dangerous, which wouldn't have been possible 2 years ago. And I thank the fact that I'm working with people who are happy with AI, but my God, they still understand algorithms. So, end of story. The happy result of this is, as a technologist, you've got to understand you are still smarter than AIs, but you're really stupid if you ignore what the AI does to help you. As a business person, you've got the responsibility to never tell a CEO or a general, yes, this is easy, everything's automated now, because there really is a lot of pain to make it work. And that is the end of my story, and I'd be happy to take questions if there's time.
What category was under at the end, if there was a resolution to that discussion, where the category was falling under in the Google?
What was the answer to that question?
It was a discussion, but then what was the answer from an ontological perspective?
I'm going to have to get back to it. Maybe it's a trade secret. I don't know.
Serious question, though. So you talked about knowledge graphs, right? And do you see now a coming back of more constrained representation languages beyond the knowledge graphs? Because the knowledge graphs are telling us entity A is related to entity B and so on and so forth, but not many constraints that can enable higher level reasoning. And so in what you're building, in what you're seeing in the state of the art, do you see more of those being built around as a scaffolding to LLMs, generative AI?
Yes, so this is a pretty technical question about, I didn't really talk about what my company does, and actually that's intentional because we're doing our big coming out of stealth moment in a couple of weeks. But loosely speaking, it is about representations called context engines, which live between the LLMs and the raw data. And those representations, especially when you're looking at a combination of traditional knowledge graph facts about entities in the world and the movements of things, means that some of these questions like identity management, is this phone number the same as this email address? Is the person who worked on this ship the same as the person who is traveling in this bus? Those kinds of questions. Doing those resolutions themselves requires more than the traditional master data management type of work that many of us are familiar with from the old days. It involves clues like looking for coexistence, co-travel, co-behaviors, and doing those kind of inferences. The thing that I love about the world right now is I can afford to do those massively expensive things at a scale where I can build a knowledge graph of billions of entities and trillions of connections, and I can just do it. I don't have to spend 3 years building up the organization to do it and 2 years fighting for the funds to create the supercomputer. These things you can just do now.
Hi, I'm a digital product designer, and I wonder, in the midst of all this, what role do you see product designers and product managers playing, and how might that change?
Very good point. I think what I've been trying to do with my organizations, as we've seen this approaching, is moving the worlds of product design and engineering closer together, so that just as in the old days we maybe had statisticians and machine learning engineers, and we turned them into one kind of group that we would call data scientists, this kind of high-level engineering, you might even call it something like design engineering, where a huge amount of the effort goes into defining the scope of the problem that you're going to give your armies of agents to work on, is really important. Now, the good news for you is usually product managers are outnumbered 1 to 10 by engineers. So as we try to create these superhumans who can really do both, you're going to be very much in demand.
A big time is the centralization of power within AI to a handful of companies like Anthropic, Google, OpenAI, in terms of controlling the algorithm and controlling the output. If that kind of leads to the castles on the hill in the cyberpunk type of future going on below it, where do you consider the viability of a decentralized alternative like BitTensor, who might take the power away from these 5 companies and put them into developers, miners, business owners?
Really good question. So there's 2 sides to that. One of them is just the wealth disparity, and I'm not sure. I don't think that's what you're talking about, but I could easily see a future of, the 0.1% living in absolute luxury and utopia while everyone else is living Mad Max. I think that is a reasonable. No, it's not reasonable. It is not crazy to imagine a world turning in that way unless we citizens do something about it. But the second thing about who controls the keys, whether, for example, if Google misses out on a really clever way of adding value in AI that it didn't think of, and some CMU grads think of a startup example and do it themselves, there's the question of, will Google crush them? Will it, at a very early stage, bring them in, partly to take advantage of their skills, but also to remove competition, or to allow them to thrive? At the moment, I have a small company. I'm lucky that I got friends in all of these big companies, so I've got a certain degree of protection there. But the one thing that keeps, I think, folks safe right now is that it isn't just one company. And so the minute that, say, Palantir acquired a major competitor of what we're doing, we become much more valuable to everyone else. And a lot of the smaller guys are benefiting from staying in that region where, honestly, especially for these enterprise AI applications, it actually, I say this with humbleness because I was responsible for this. It's really, really, really hard for a big company like Google to be useful to banks and to retailers and to trucking companies and to hospital systems. They're actually, it's really, really stretching the I mean, we at Google, we did have ambitions for selling products in all of those fields, but it doesn't take long before you realize that all the resources you're putting into staying ahead on the raw technology means that you're looking for other smaller folks to take advantage of the platforms you're building to grow. So Google and other people do want this system out there of folks coming up with smaller success stories in these other worlds. But I will agree, in some ways, I'm scared that the world is solidifying. It might be that there is not another FANG company created, because these days, if someone looks like they're just 3 years away from becoming one of those companies, they will be bought by one of the big guys who will continue to grow. I enjoyed it. Thank you very much. Thank you.